rate is m of x equals negative 2x squared plus 6. We have three things happening. The negative sign in front of the 2 means that it's going to reflect in x-axis. The 2 in the A spot means that it is a vertical stretch by a factor of 2. And the 6 means that it is a vertical translation 6 units up. So when we go to graph this, let's use those rules. Parent function, like I said, you don't have to have this, but some students like to have it so they can refer to it. We're going to reflect on the x-axis. Okay, so we still start, actually we don't start there. Let's put the parent function back in. But we're going to translate it 6 units up. So all of these points will go 6 units up. I'm going to concentrate on the vertex. It will now be at 0, 6. And instead of going to the right 1, and if we're going to reflect on the x-axis, instead of going down 1, we're going to go right 1 and stretch that by 2. So multiply your vertical movement by 2. So over 1, down 2. It'll be symmetrical on the other side. Instead of going over 2, 2 squared, 4, so over 2 down 4, we're still going to go to the right 2. 4 times 2 is 8. So to the right 2, so we go over 1, 2, and down 1, 2, 3, 4, 5, 6, 7, 8. Bam. So realize that we're going from the vertex. When I say over 1, down 2, you're going from your new vertex. All right, let's get rid of all of that. Put our vertex back in and connect the dots. Again, if you use the table, your vertex is at 0, 6. So if you use 1 and you throw it into the equation, m of 1 equals negative 2 times 1 squared plus 6. 1 squared is 1 times negative 2 is negative 2. Negative 2 plus 6, that gives you 4. So when x is 1, y is 4. That's what we have right there. And then if you did m of 2, so this would be 4, negative 1 would be 4, and then for 2, you would do negative 2 times 2 squared plus 6, so negative 2 times 4 plus 6. Negative 8 plus 6 gives you negative 2. When x is 2, y is negative 2, which is what we have right there. And then just make it symmetrical on both sides. Okay, last one for this video, for this section, n of x is equal to 1/3 x squared minus 5. So we have 1/3 x squared minus 5, n of x equals. So we only have two things happening. Let me just make sure I wrote it down correctly. We have an a of 1/3. So we have a vertical shrink by a factor of 1/3 and a vertical translation 5 units down. So since we're going to translate it 5 units down, we are not going to start at 0, 0, but instead we will start at 0, negative 5. So that's your parent function. We'll start at 0, negative 5. And we can do the shortcut. The shortcut is usually go over 1, up 1. So we'll still go to the right one, but 1 times 1/3 is 1/3. And then over 2, 2 squared is 4. So still go to the right 2. And then 4 times 1/3 would be 4/3, which is 1 1/3. And the reason why I hesitated to do it this way is just because when you're dealing with these fractions, you might be a little bit hesitant on how to graph them, it's always nice to grab numbers that are multiples of the denominator. So in the parent function, if we went over 3, we would go up 9 because 3 squared is 9. So we'll still stick with going over 3, but if you have 9 times 1/3, that gives you a nice number of 3. So let's graph those. Okay, so over 1, and I'll blow up my graph, up 1/3 is about here. And then we have over 2, up 4/3. So 4/3 is 1 1/3. Over 2, up 1 1/3. And then the nice point will be over 3, up 3. From the vertex, over 3, up 3. And this would be, let's make them a little bit bigger, your graph. Again, feel free. If that's not for you, use the table. You know your vertex is at 0, -5, and then I would grab numbers that are multiples of your denominator of 1/3. So you have denominator of 3, you could do 6, -3, -6. So we already know that when x is 3, we go up 3, but the actual number, we're going to 1/3 times 3 squared minus 5. So 1/3 times 9 minus 5. So this would be 3 minus 5, which gives you -2. So when x is 3, you go down 2, and that's what we have right there. And then it would be symmetrical on the other side. If you wanted another point, 1/3 times 6 squared minus 5, 1/3 times 36 minus 5. So then this can simplify. 3 goes into 3 once. 3 goes into 36 12 times. 12 minus 5 gives you 7. So when x is 6, y is 7. And we would have that point right here. And that would just continue to follow on the left side too. And you don't need that many points by no means. I'm just trying to show you different ways to graph, different methods.